Hey everybody, let's go ahead and get started. I hope you all are having a great day so far. I'm doing okay now. I was a bit, I don't know, after about 2 o'clock today, I was just knocked out tired, but feeling a little better now, so I think my brain is awake enough to do some more geometry. Uh, Hopefully anyway, otherwise the stream will be for not, but let's go ahead and go over to desktop. Okay, so today, firstly, let's go ahead and open the project. See where we left off. So we've got margins subdivided. These areas right here are the margins. And they blend fine and everything. But obviously we have these holes in here, and that is the corner triangles and also 2 other extra little triangles right here. So we need to first make these triangles, and then we're going to need to build this whole like corner shape here. Alright, so I think I tried something where I could like just loop one more time here, but I don't think that will actually work because the distance from this endpoint to the next corner here is probably not the same as it was there. I think it ended up looking kind of strange. Okay, well actually, it seems like Unity is clamping it there. But yeah, if we just flip this over, we can see it probably goes too far out. Probably because this lerp clamps this value between 0 and 1, which is usually what you'd want. Okay, so gosh, this is getting pretty big. I wish that there was some way to condense this function, but I don't really think there's a good way to do it. Yeah, I can't think of anything right now. Well, really, each of these loops is just one function call. It's just that this function call takes up a lot of space. So I don't really like how large this create margin ring is, but I don't know if there's any way to really make it any more concise. But okay, so anyway, we need to make the create two triangles which overlap the corner margin. So basically we're going to make this one and this one. So this first one is like, yeah, the second loop, except the ending point is not the same. Okay, so yeah, we're going to have to figure out this here. Okay, so look, so this is the margin. I'm just trying to figure out how I can find this line here. I guess what we have to do is find the center point, which is kind of the average between these 3 points. And then from there we can draw a line from the center to here. Well, I was going to say, a lot of this code is going to have to be calculated again when we make the this corner triangle shape, but I think that's just gonna, we'll have to think of some way to share that code, but I'll worry about that when time comes. Okay, so let's see. So we need to get this other cell. Which is just, okay, so it's a neighbor cells, then one clockwise from the side. That's pretty simple. Then we just need to get the average between these 3 points, which we already have 2 of them. So what if we had 2 loops here, or 2 subdivisions? How would that look? I guess we'd still have the center point. I'm just trying to figure out how to make it extensible, but I think it has to be odd at all times, doesn't it? Yeah, because there needs to be the center. Otherwise the triangle I think would look kind of strange. Okay, so yeah, first let's find the triangle center point. Which would be... Okay, yeah, so I don't want to use the LARP yet because we're just going to try and find that center point, which is the same no matter which ring we're on. So I get these 3. And we'll need to take the average of them. Okay, so that will give us this point right here. So if we want to get, so if we only have one subdivision, then that line would go straight through the center point. Yeah. Sorry, knocked the microphone there. Okay. Thinking, and now that I'm looking at the diagram again, it looks fine here, but we have relatively thick margins. Hard to see where the margin starts now. But what I'm thinking is that I might want to actually redo the way that I've drawn the, or making the subdivisions. I think just so I can see what's going on easier, I'll take off this bump position. We'll just comment that out, and we'll just return the flat position. Oh, okay, I didn't. Yeah, that's kind of annoying. Fortunately, I had to have two separate functions for that because the bump position for here does not care about the backup block prototype, but just to save time, I had to do it like that. I'll actually need to make a third one because the triangle will have 3 prototypes that has to alert between. Okay, so now we can more clearly see the margins. So here, okay, no, it just has one line. Okay, that's what I wanted. Yeah, I was just thinking, I don't want. What happens if we have 2 lines? I want to see what the game does at that point. Okay, so I actually have the subdivisions at 0 right now. Oh, well, no, it has to be like that. Just because, yeah, the way that we're going to have to do these meshes is that they'll need some line to be in the center in order to line up with a triangle. But I guess if it's 0, then these should just like match up exactly. Oh, but no, that's not possible because of the way these triangles are created. So yeah, this is just gonna have to be the minimum number of triangles. Let's see what happens when I take down the hex subdivisions to 0. This would basically be the simplest possible geometry. Okay, so right now it looks kind of strange because these triangles are supposed to go into the center one, but I think this is still working fine. So if I bump this number up, let's see what it looks like. Okay, that's still okay. Yeah, that's how I wanted it to be, I guess. I was just misunderstanding how the number that you input into the mod corresponds with the number that the game generates, or the number of divisions the game generates. Let's just add this something simple and look at how that is. Okay, that's all good, I think. Yeah, the reason I was thinking about this is because I want to make sure that these margins don't have too much geometry by default, in case the mod authors want to have like really small margins, but I think it'll be fine. But anyway, after that little detour, I think I'll just leave these flat functions off for now, or the bump positions. So we'll always need this center point because no matter what, there's always a line through the middle, which is good. And then, so for this triangle we need to find this point, which, okay, so if we're on ring 0, that's down here, and ring 1 is up here, but I would actually need this point. Okay, so yeah, we're gonna have to see, it's slightly different depending on if the ring is above the halfway point or not. And then if there's only one ring, the first triangle will go here and the second one's there. Okay, so I think how I'll do it is just based on the LARP value. If it's above 1/2, we'll LARP from here to here, and then if it's below 1/2, we'll LARP from there to there. I think that's the simplest way instead of trying to tell if the ring is above a certain point. Okay, so anyway, for this first triangle is here. This point is simple. Let's start at this one actually. So that is this one. Except we can make it even simpler because we know it's going to be the last. Add. Oh. Okay, so we don't have to LARP, we can just give near corner B because we know it's at the end. I didn't need to copy that over. We just, oh, we do have to have that bump position. Okay, and then the next one, going clockwise, is up here, which is mid position. But yeah, we will have to LARP that. Look here. I'll need to make sure that this value is okay, but the T is database hex rings plus 1/2. That seems like it'd be wrong, but I'll just go with it for now and we'll test it out. Last but not least is this value. Maybe I should have like a special LARP function I can call. Private vector 3 triangle LARP. Okay, so I'll have a, or no, I guess we'll call it near vector far and vector 3 center, and then I'll need to have the LARP value. And again, if LARP is less than 1/2, we'll transform between near and center. Turn vector 3 LARP from the near to the center, and that would be this LARP value times 2 because we need to go from 0 to 1 instead of 0 to 1/2. And else return vector 3 LARP from the center to the far. This time we need to do LARP minus 1/2 times 2, because when LARP is 1/2 we need to change this to 0. to get to the center, so that's why we subtract a half. And then when lerp is 1, we need to change this to far, so when we subtract 1/2, multiply by 2 to get this back to 1. Okay, not too painful. So now instead of just calling vector3 lerp, I'll call it triangle lerp, and first is near corner B. Well, no, it wouldn't be in the near corner. I just pass in these center points. So my point is the near side and the far one is the neighbor. Right, because we're trying to go right here. Yes, from me to my neighbor. The triangle, center point, and this would be supposed to align with this, so that'd be the mid lerp. Then I need to pass in all this other bump information, of course. And finally the colors, so near color, mid color, and grain. Here, color. I guess these should be shifted back 1 tab. Alright, so let's just test this out. In fact, I think I'll... Well, no, I was going to say maybe I should just have a separate function to figure out this triangle center point, but I'd have to pass in a lot of stuff. I'll wait to do that. Alright, so let's find a flat one. Okay, so it's doing it over here. Oh, well that's fine, because it's, I'm looking at the bottom. So on this one, yeah, it has these 2 triangles, and they seem... I think that that's correct. It looks a little weird right now just because they're not the same length, but... because we have to fill in this corner portion. Yeah, but it's definitely a straight line from there, which is what we want. It should go to the center of the triangle, which is about right here. Is this part correct though? Because... okay, well no, it does go. It follows that line to the center. It just looks a little weird. Okay, so let's make this second triangle. Second triangle starts... let's just have it start there and go around. So first we can use this point again, which is that one. And then next we'll use this point, which is the far corner B, so we don't even have to lerp. Gotta call bump position though. My cell surface, neighbor cell surface. Okay, well these, yeah, I just realized these bump positions actually need to take, since they're in the triangle. They need to blend with the triangle between the 3 colors. I think about it. Do we need to have a cutoff right here just because for color blending. I think we might, because past this line we don't want any of the third color from the neighbor to blend in. Yeah, so for it to blend correctly, I think we will need to actually just have an edge right here. Not a huge deal, but it will make this seem a little more obvious in when we create the bumps, but I guess that's just going to be how it has to be. Otherwise the colors would be weird, because it's like it would pull more from this color in kind of a sawtooth pattern, because these would have part of it, but then this triangle wouldn't. So it would kind of like wave in and out like that, which I think would look bad. Yeah, and I don't think there's any way that we can just like linearly average so that the color would stop right here. Alright, well that makes this part a little simpler for us, but I already have this code, so we'll use it later on in the triangle. Okay, so let's redraw this a bit. I need these after all. Back to points, and same with this. I guess. What is going on? Get rid of this triangle and then just extend this point over that. Okay, so now we just need one triangle for this point. Might want to still have two. I'll just try one and see how it looks, but it will be kind of weird because this line won't extend the entire way through. Maybe that's okay, let's try it out. Okay, so the first one here is just corner, or near corner A, and then this halfway, and then far corner, or near corner B, sorry. And then it's midpoint, and then far corner B. That's actually pretty simple. I already have the first two set up. So if I just copy and paste and change this to values for the far node, that should create that triangle. Okay, so now we have a line there. And I guess we can create this one, or these as well now. Yeah, we're gonna just need to test these out and see what looks better. And I think I can change this from A, or from B to A, and that's all I have to do there. And then this just becomes 0.5. Yeah, it is 0.5. Oh, did I delete the wrong one? Yeah, I deleted the second triangle. I did something wrong because it wound. It's probably round wrong. Which, yeah, upside down we can see them, so that means, again, I didn't do it clockwise. Okay, and so that's because right now I'm doing it like that, which is counterclockwise, so I just need to switch these around. Okay, there we go. Thing looks fine here. So if I add in bumps, I'm just worried that the center will kind of look strange. But I guess we can't really test it out all the way until I get in all these holes filled in. But might as well try it as it is. I guess if it looks weird now, then it'll probably look weird in the final product. I don't notice anything too bad. Bit strangeness right there. Doesn't really look bad necessarily, but well, let's just continue on. If there is an issue, all we have to do is just add, like, split these triangles up. So it's not that much work. Alright, so now, for now we're done with this. And then I just need to, if we're gonna make the triangle, I guess I'll leave this commented in case I need it. So create margin, let's call it corner margin, section. Yeah, how will this actually work? Section 1 is like that, but section 2 is... Yeah, so actually what we should do is put this into 3 and... Maybe the easy thing to do is actually for each margin just have it create, whenever we create this rectangle side, it'll also just create this corner here for both sides instead of doing the whole triangle. So we'll change a bit of the way that we handle it. I think that will be much easier. I guess if that's the case, then we don't really need a separate function for the triangle. Okay, so let's make this one even huger. So this will be the clockwise corner wedge. So for the first ring, we do this part, or no, just this part, and the second one would take care of this part. And our triangle LARP will actually make that easy for us. So, but we have this triangle here, which... Will we ever have like another line through here? Let's just say no for now. I might need to add that later, but... Because like I could see that maybe... You'd want to like have like another loop that goes through like that if the triangle gets really big, if you had huge margins, but I don't really know if that'll ever happen. So basically all of these wedges are going to have pretty much just constant triangles. Just two. Got this one and this one. Okay, so I already figured out this point, and I already know this point as well, so it's actually going to be pretty simple. So this will be the clockwise other cell, and the clockwise triangle center. So I just need to add 2 triangles for this. Let's do this first one. So if we go clockwise around it, I'll start here at far corner B, and then we just move to near corner B, then far corner B, and then this point right here. I guess I'll copy this one because it's already set up like that. And again, I need to make another version of bump position that will have 3 prototypes to LARP between. So this third one is we need to use a triangle LARP. And we'll give it the near and the far. Oh no, we actually give it these points again. It's the mid LARP value, isn't it? Oh, and then it needs a triangle center. Let's look at that. And I'll figure out how to get it to blend with 3 colors. Oh, yeah, I don't need this anymore.
This is the mighty jungle.
Okay, something's not right for sure. Yeah, they're flipping over to the wrong side. Oh, this should be B's. I think that will be it. Okay. Oh no, that makes sense. I was gonna say that's a little strange if they meet up like that, but no, that's because it's winding around like that. Yeah, so it looks fine, and these meet up perfectly. Now we just need to make this triangle here. Just goes from this point again to the center. Actually, I think I could save this so we don't have to calculate it twice. Vector 3, clockwise, triangle mid. Okay, and the next one starts at the mid and then goes up here and then to the triangle center. And the triangle center point, these prototypes don't make much sense, but that's just because we need to change the way we do the colors to switch between 3 again. Yeah, actually I'll need to make a new terrain as well. Far. Let's look and see if the geometry matches up. And we'll look into blending when we're all done. Oh no, something weird. Is it reversed? No. Okay, I bet I just got the wrong variable. So do this midpoint first, and then we need to go to the far corner B and then the triangle mid. That should work. What's it not like? It's created there. Or yeah, it's just like right here there's what's going on there? You can only see the edge. This one's fine. I'm gonna see if there's some pattern. Let's get rid of the bump again. Bump wasn't the issue, but it makes it a little easier to tell what's going on. Weird. I'm just gonna rewrite that triangle because I probably made some mistake. Okay, so the first one we want to do a bump position from the this corner. I'm going to go clockwise around. That corner is the clockwise triangle mid. Be the mid lerp. Oh, I have too many parentheses. Bump position. Next is the far corner. Copy from here because we know this works. And last is the triangle center, which is clockwise triangle center, and it doesn't really matter right now. Okay, so now we pass the colors. Mid color, far color, rain. Okay, that didn't help, did it? But I just realized we also we might not always go up to the center. In fact, how would that look if we added another loop here? Because that would add more geometry. Yes, this code I'm doing might not fully create a triangle if we have another margin loop. I think that's the issue that I'm having right now as well because, oh wait, no, margin subdivisions is 1, so it should match exactly up what I'm making right now. I think, let's see here. If I pick up another triangle, create one real quick. Big. And we say we have another subdivision, so this. So we have 2 points at the end, and then also this middle point. I guess first we should just do a 1 subdivision triangle and see what the pattern looks like there. That means there's only that one line there. So yeah, this only has 1 triangle. Very easily. But this one ring should make both of these, and so this part is obviously not the center triangle. I hope that it's not always different no matter what the number is. There's got to be some way to generalize it. Okay, now we have this case where we have an extra subdivision which adds 2 lines right there. So one ring would have that. How am I doing it right now? I do one like that. Oh, I see. So I don't actually connect up with this middle part. That means right now this will actually just have 1 triangle. But I guess that begs the question, do I want to go ahead and assume that I would have a straight line here? I'm kind of assuming, I kind of think that it might look better like that. Which is that thing I was talking about earlier in the stream. Yeah, I think I'll go ahead and do that. That means that this will have triangles like that. Maybe I don't need this point in the middle. I mean, these triangles will be kind of big, but okay, if I just kind of make them like the hexagons where they radiate from the center, and then if I want to, I can add margin rings around here. I think that will look better. Let's actually get rid of all this because it's not current anymore. So now basically for every extra loop, we would just create another triangle going to the center. Get the point, but I'll go ahead and finish up this diagram. Wait, no, one more. Okay, so that is a bit simpler, and there's some general algorithm for every orientation. For one ring, you cover the whole side, and then when you have two rings, oh right, then you do half, and then when you have 4 rings, a quarter. And now I don't even need that triangle lerp function. I guess makes sense, that was a bit messy. This also makes it a lot easier to blend because these triangles on this side actually would have only, for example, the red and green value, and so they wouldn't even need any blue, but the center one would have, I guess, a third of every color. And so naturally the blue will go in towards the center. Yeah, I like that much better. Okay, so we still need the center, but we don't need this midpoint. But I will need the clockwise terrain, which is just the same as the previous terrain, except we add in this clockwise other cell as the blue value. And I gotta get terrain index in case it's null. And the triangle center color. Clockwise. Oh, well, this is actually the same for each, but color is, I'll do it like this so that I won't have to type out 1/3 divided by 3. Okay, so get rid of all this. It also makes this bump position a lot easier. But if we, yeah, like sometime later I might want to have another variable that mods can set, which is like, I don't know, triangle inner rings, and then we'd have another loop here. That'd still be a lot easier to calculate than the way I was doing it before. This. Okay, so the number is just, it's basically the number. This has 0 rings, so it's number plus 1. It's actually times 2, it looks like. Margin times 2 is how many Oh, actually, every time, each ring only... Oh yeah, that's actually really simple. Each ring only has 2 that we have to make. What's going on with this triangle? That's all wrong. And yeah, sometime I'll go back. We'll change that triangle to look like that. Yeah, so we always just have 2 triangles here, and it's just from here to the triangle center to the mid, and then mid, triangle center to far. So that's really simple. Cool. Yeah, so near, oh, gotta go clockwise, so near, mid, center. Oh, right. Gotta take care of the bump positions. So for this, well, no, these position is actually the same because we don't take into account. The good thing is that all these points are either on the edge or in the center, so we don't have to worry about this third type. But when we figure out the bump position for the center, we will need to worry about it. But anyway, let's worry about that last, I think. D. Copy this, I think. Mid. I don't have it. Oh, yeah, it's just called midpoint, not mid-corner. And the triangle center. And this doesn't make any sense, but for now I'll just leave it. So here color, mid color, triangle color, and then this is clockwise terrain. Oh, this should be a color, not a vector 3. And the next triangle is nearly the same, except it goes from the mid, the far, to the triangle. Okay, so we're at this approach. Okay, yeah, looks good. Yeah, so this corner looks weird because we don't have this edge. I think I'll go ahead and add it. So I'm going to change this triangle to go from here to this mid just to the edge here. Oh, I'm actually doing the other side, it looks like. Fine. I forgot to update this, didn't I? Those are gone. Clockwise, yeah, should be near to mid, and then, oops, I did it wrong. That. Next one would be mid far to this point. Now mid to far. Okay, so I'll just comment that one out and let's look, see how that looks. Okay, yeah, that's fine. And so now this edge goes all the way through, which I think will look better in the long run. So next part, kind of copy this, and we need to change these A's to B, and then we need to flip the points around. That stays. We calculate this point here a bunch of times. Now this function is not the most efficient because we do bump position a bunch of times for the same points over and over again, but I'm not going to worry about it just yet. So in order to stay clockwise, if we want to start near, we've got to do this middle point first. Same with this, we flip all the A's to B, and then I've got to just change this to the bottom. Mid and far. And okay, I was gonna say it's good, but oh yeah, they're moving back to this point when they actually need to just go here. I think yeah, I just need to change the way that LARP value is calculated. Instead of it just being 1/2, it needs to the number of rings plus 1/2. Try that one more time. Alright, so now we don't have any more phantom triangles moving back. So now I just need to do this little wedge here, which is the same code as before except in the counterclockwise direction. Get rid of that. And this triangle center color, same for all of them. We'll just move that there. Okay, and so the counterclockwise, counterclockwise, and so that would be that point. Look back up here, we want to get this point on our counterclockwise neighbor, so it's counterclockwise neighbor and then rotate the corner over twice. And so to get counterclockwise, we add 5, get the other cell, and then the point we want is twice. Every time we talk about the clockwise cell, we want to change it to counterclockwise. And I think that's it. Oh, I bet they're wound wrong. Yep. And they also go to the wrong point. But let's do one problem at a time. Oh, well, they go to the wrong point. I was gonna say because this is the wrong thing. Oh, I think I messed this part up, didn't I? Yeah, so we want our side. Yeah, we don't even have to rotate that around, but we want to change this to be +2. And the neighbor is actually, I think, +4 because right here. And to fix the winding, so basically looking at the triangle from this side. We'll just change the center point to be the middle point on the triangle. That will do it. Something's still not right. Oh, they're using the wrong point as their starting points. That's because all these corners to be on the counterclockwise side, which is A. Dangers of copying and pasting code, of course. Okay, so now everything looks right. This is a little strange. I'll leave it for now because I'm not exactly sure how I want the edges of the world to look anyway. But probably we'll need to either fill this in or have these be cut off at that point. I don't know. We'll probably need some special case, but we'll take care of it later. Okay, so looks good. Let's mess around with the different numbers of rings here. Bro. The good thing is that these triangle sides don't care about the divisions of the hexagon. Actually, this looks really good because the triangle sizes are all about equal. Let's just test this at, I don't know, 2. Which is way overkill for the size of margin we have, but yeah, no bugs. Let's try something crazy like just set these both to a high number and see what happens. Yeah, this is starting to be a bit much. When you have a bunch of things that converge on one point, this cannot, like, it might look strange. And it looks fine here because everything is flat, but yeah, if you had actual bumpy texture there, I think this point might stand out. So we definitely want to add another ring, but not really needed right now. So if I set these both to 0, let's see how that looks. Both ends of the spectrum. Yeah, that's perfect. Okay, so we've done that. Yeah, we probably want to update this. One other thing, investigate the margin, triangle, ring, subdivisions, and breaking up the center point. This is what I was talking about, some way to maybe make everything not converge onto that point. But unless for some reason the mod had like huge margins, which would be kind of strange, I don't really know why they'd ever have more than like 1 or 2 loops in here. Okay, so the only other thing we need to do, let's add, before we go further, let's add back in bumps. And I think this will illustrate one other problem we have, is because these bump positions don't get lerped correctly for the triangle. In the middle triangle, it needs to take into account all 3 prototypes. There might be a hole, but I guess it depends on how everything comes together. Yeah, right here you can see there's a hole because from this side it only takes these prototypes into account, and then here it takes these 2, here it takes these 2. So it needs to take all 3 and average between them. I like the way that the bumps are looking right now. They're a little chaotic. I think that they're too strong, but... And it's weird that you get this kind of like rocky texture out of having the checkerboard pattern. Alright, so what we need to do is just have a 3rd version of this bump position for 3. And I think I'll move down this version of the bump position just so that they're all next to each other. So we'll have 1, 2, and 3. Look, proto type. Alright, so I'm trying to figure out how we would lerp. I guess we'll want to know how close we are to the center of the triangle, and then how close we are between A and B. Lerp A, B. Lerp center. Okay. I need to change the way this works a little bit. We'll actually want to get float height A. Just, I don't need to save the whole also. R. And then I'll need to go ahead and declare height B and height. Okay, and then we'll need to have different links as well. No. Yeah, I can't do it this way because these values will be different depending on which one of these are null, like what combo. Best way to do this. I'll just delete all that for now. Let's say if proto B dot, or if that equals null, and proto C equals null, then we'll just only depend on prototype A, so we'll just return bump position proto A. It doesn't need a lerp. Then if proto B is null, then we'd return just a 2D bump position, or not 2D, but between two. And what's the lerp here? Well, this is obviously just the lerp AB because the third point doesn't count, or doesn't exist. If, oh wait, I did this backwards. This should be if proto C is null. If proto B is null. Then we would kind of need to just do the normal algorithm, except the average on the flat side of the triangle is only taking proto A into account. Yeah, so I think we'll just like that. Right, A is this dot R. And I won't worry about the links for now, just for simplicity. Joshua Gallagher, thanks for coming by. How are you doing tonight? And then if proto B null, great, glad to hear it. Then okay, so these stretch values are what complicates it a bit. Oh, you're starting to make a game? Sounds cool. Or not really a game, you say? Or just like something to play around in or something? Let's see. No, if this does equal null, what we really want here is the height border. If this equals null, then the height on the border is the height A. That's definitely a good way to learn, at least how you could change it into a game in the future. Sometimes they're just as fun to make anyway. Otherwise, do something like this. I guess I really could have just called bump position. Yeah, I could just use this 2D bump position. Oh wait. Because I know I just need the height and the length. I don't want the actual. I want to reuse this logic, but I want to get the height and the length from it and not the actual position. Values. And then we'd set out float height 01 and out float length. Just copy that. Okay, so we do need the flat position actually. Flat. Oh, come on. Position. Okay, and now I can actually rid of all that and call this position values. Typing float. Okay, so now I can reuse this again. And the lerp would be lerp AB. Okay, so now we just need to figure out how to extend this in the third direction. So it at most goes halfway towards the blue. But I guess still this would be mostly the same. The height. Hi the Cameo, thanks for stopping by. You're not familiar with C#, does it have pointers references? Technically you can do it, but normally that's all managed by the C# compiler, so you don't have to deal with it. Okay, and I just realized... Oh yeah, that's right, the ref keyword is just for parameters if you want to get... It's basically for multiple return values, really. Or to pass reference values by reference. Okay, so I just realized here I already averaged the height, but in order to get a correct value I actually need these separate. Same with the length. Kind of annoying. Pass 4 values out of here. Right. Oh my gosh, I completely lost track of time. Well, I want to finish this. Okay, so in this case, height A and height B are the same. equals link A. Go ahead. Like this. I don't know why I saved the fire color. This. And now I don't need to set them right there. So again, if this prototype is null, then we just use the prototype A's values, otherwise we'll read it again. Oh, that was a bug. I changed out the prototype B. Guess now it's done. Dot red. B, we won't lerp them yet. I guess we don't even need this lerp value here. Now I wonder if this function is even really needed, because it doesn't actually do that much. Let's just make a separate function, get bump height, and we'll just take the flat position. Wait, float again. Not potion either. And let's take one prototype, and it'll just read the height for that one prototype. Got the UV. Then we just return that. Okay, and now I can just call get bump height, typing float. Alright, and then the closing parenthesis. That's actually kind of messy, isn't it? Float that. And that looks good. So I don't think this function is not going to really serve any useful purpose now. Get rid of that, and then I actually flipped these around. This should be height A get bump height for the prototype A. Flat position. Oh, I did it again. So used to typing float. And float length. Right. Oh no, I guess I don't need to do that either. I could just have a complete height and length. And then if prototype B is null, then we'll just set the height and length to the A's value, otherwise need to lerp between them. That's a lerp. And again we'll call get bump height, so I don't have to read the UVs again. Let's alert these. Oh yeah. the lerp argument. Okay, so yeah, I'll just get rid of this function. It's a nice idea, but not that helpful. Okay, so now with this, I need to get, because I have to get the height for all three regardless. And I can't use this because it was going to go ahead and average them, and that would give me a wrong value. So I can copy this. I can kind of copy this, but slightly different, and different enough that I can't use that function again. Oh yeah, and I don't need this UV anymore. And obviously we can't lerp, that was the whole point. And so we've already checked to see if prototype C is null, so we know it's not. So I can just call this one more time for that third set of values. Alright, so I'm trying to figure out. Basically, we gotta do a 3D lerp. So maybe I could have done it the way I was doing it before, but didn't want to get the average wrong. Well, this isn't that much more complicated anyway. So the height. When you add vectors, I mean, you can add them in one direction first before the other one, and that will give you the correct answer still. So if we found the answer along this line and then moved it towards the center, that should be okay. Getting a bit late. Alright. Yeah, I really need to go. I'd like to finish this, but an error. Oh, it doesn't return the position. Well, that's okay. So we just need to do bump height for the triangle center. And I guess I'll do that tomorrow. Sorry I couldn't finish it up, but you know, it's getting late and I really have stuff I need to do, so thanks everybody for coming by and watching. I do appreciate it a whole lot. If you want to catch up on any stream, I upload everything to YouTube, so you can check there. Also, feel free to follow me here on Twitch or Twitter to be notified when I go live tomorrow. I'm planning around 8:30 Eastern like usual. And I also have a Discord channel if you'd like to chat with me and other viewers. We'd really love to have you there. You can reach any of those places by typing !YouTube, Twitter, or Discord and chat, or also just looking in my channel or video description. And yep, that's my outro. So again, thanks everybody for watching. I do appreciate it, and I hope you have a great night. Okay, bye-bye.